get the best out of the semantic search, it's good to know how it works and why it works. And that's why I'll first briefly talk about three important ingredients in semantic search: the embeddings and the models and the tokens. Most of you might be already familiar with these things, but for those who don't, it's useful information, I hope. Then I'll show how to set semantic search up in Liferay, and finally we'll see how it performs compared to standard Liferay search. I hope at the end of this presentation you'll have a good sense about what can be achieved with semantic search and what's the price for it. The resources I'm going to use here, blueprints and elements, can be found on my GitHub site afterwards. Why to use semantic search? So traditional search is based on keyword matching. This means if you are searching for healthy snacks, like on the screen, you'll only get results containing at least one of the words healthy or snack. And while that's often good enough, you could also get results like poisonous snack or health inspection. But semantic search avoids this problem. It doesn't rely on keyword matching at all, but only on the semantic similarity between your keywords and the results. With semantic search, you can get results that are about healthy snacks. The second big benefit over traditional search is usability. In traditional search, the search phrases have oftentimes to be composed in some certain ways to get good results. In semantic search, you can search as if you were asking your friend. It's easier and more intuitive. So when semantic search is well set up, there's a high likelihood to make users happier. Now, let's take a look at embeddings, models, and tokens, what they are and why they matter here. First, the most prominent ingredient, the embedding. This is the secret sauce making it possible to find semantically similar results. To make an asset, for example, web content searchable in Liferay, we need to store a representation of that to the search index. This representation, what we call a search engine document, is optimized for searchability. But to use semantic search, we need to add something to this representation, and that's the embedding. Embedding is actually yet another representation of the original asset, so it's kind of representation inside a representation. Let's take a look at what an embedding is about. Vectors in data sciences, they help representing objects in ways we can measure how close or related they are. And semantic search takes advantage exactly of this. It creates vector representations of assets so we can measure how similar they are to our keywords. An embedding is actually an encoding of the semantics of, for example, web content or file entry in the form of vector. We need something to create this embedding, and that's what the model is here for. So literally spoken, the model models the source data to an embedding. Model is the heart and brain of semantic search and is ultimately what the semantic search shines or falls with. Now, what does an embedding look like? Obviously, a three-dimensional vector, like in the first image, it cannot represent complex objects. An embedding has at least hundreds of dimensions, nowadays usually thousands or even tens of thousands. To give a sense of how this kind of monstrosity looks like, this eye burner here is a 768-dimensional embedding for, well, test. Now, one might also wonder, what do all these numbers actually mean? So each number is actually representing some characteristics of this text. They are something we call features in machine learning. If we flip this vector into a table like this, the intuition looks like this. The right column there is some feature. It could be like relative number of verbs or tone or etc. And the left column is there the dimension or vector component giving a quantity for that. In reality, these features are not human-generated, but computed automatically into neural network. But this is the intuition and the mechanics. Now, this is something I think most of us have encountered with chat models. Different models produce different outputs. Why does that happen? There are other aspects to this topic, but it's a lot about quantity and quality of the training data, what these models have been taught with. If they have been taught only with baseball data, they can barely produce good answers to questions about farming or baking. And that's why it's important that the model we use in our semantic search solution matches our data domain as well as possible. Large language models often shine in generic data domains because of the vast amount of versatile training data. There is one more ingredient to this good to be aware of, and that's the token. When we create an embedding from a text, for example, the text is first chunked to something called tokens. A token is simply a chunk of characters, often a word or a part of word. So this here is an example from OpenAI tokenizer test page. On the upper area, I have the source text, and on the lower area, I have the tokenized version of it. Different colors representing different tokens. Now, how the tokens are exactly built depends on the algorithms used, but usually one token is about 4 characters of text in English. Why am I talking about tokens here at all? For 2 reasons. First, each model has an upper limit to how many tokens it can handle at once. So translated, there's a limit to how much text it can take as input for creating our embedding. So if I have, for example, a 2 million characters PDF, I can probably use only part of it for creating an embedding. And some of the semantics might get lost. So if your model can take more tokens, in some cases it might be better. And so this is something to keep in mind when configuring the semantic search. Most model APIs can cut off the tokens or to truncate the data, but not all. The second reason why I'm talking about this is surprisingly money. Pricing models vary, but some providers bill per tokens or characters used. In some cases, it might make sense to balance between the costs and quality of embedding with the means of token count. In semantic search configuration, which we will see in a moment, we manage this with the max character count setting. This limits the number of characters we send to the model from the source asset. 500 characters here would thus equal to something like 120, 30 tokens. Now, that of the ingredients, but let's connect the dots. How does semantic search work? So let's think about this scenario here. We have 4 text documents, and our model has created embeddings for each of those. Now, what happens practically when I hit enter on the search page? How do we find the best matching text document for our keywords? We cannot compare apples with pears, so first we have to create an embedding for the keywords too. And now when we have our document embeddings, we have the embedding for our keywords. The only thing to do is to try to find the best matching document embedding to our keyword embedding. And we can use vector calculus for that. And typically, we use cosine similarity metric for this. There are other metrics available too. We get the score for this calculation, and the highest score wins. Now, coming back to the Earth, how does this everything translate to Liferay? When we index an asset, let's say web content, we have to create an index document first. Then on the road, we call our embedding provider, we send data from our asset there and get an embedding back. And then we store that to search index. So there will be a document with embedding. This is an example of an actual index document and shows how the embedding look like. When searching, we do the same with keywords. When I hit the enter on the search bar, we again call the embedding provider. The model does the transformation to an embedding, and then the search engine tries to find the best matching document embedding to our keywords embedding, and sends the search results back. That much for the theory, and let's move to setting up. First things first, in order to use semantic search, you have to have at least the XP 7.4, update 53, and would you be interested to use Vertex AI and OpenAI providers, you need at least update 128. You also need to enable these feature flags, first one for semantic search, and the second one for Vertex AI provider. Setting up is fairly straightforward. So we first have to set up the provider account, say OpenAI, Google account, and then we have to configure the semantic search on the Liferay side. We need a search blueprint, and as a last step, we just apply the search blueprint to the search. We have 5 embedding providers available at the moment. The Hugging Face Inference API is a hosted free service. It's limited and really for testing only. Hugging Face Inference Endpoint, on the other hand, it's also hosted, but completely production grade, very flexible and for complex tasks. If you want, for example, to do custom source data processing, this is really a good choice. If you want to run Hugging Face models locally, TXT AI is the choice for that. Set it up in a Docker, select the model from Hugging Face, and run. It's super easy. Last but definitely not least, we have our robust commercial options there with impressive LLMs, OpenAI, and Google Vertex AI. To set up the first three ones of those, so Hugging Face and TXT AI providers, you can have a look at learn.liferay.com resources. It's all demonstrated there. When it comes to OpenAI and Vertex AI, we don't yet have documentation for that, but actually they both document everything quite comprehensively. So basically you just create your account there, show your credit card, enable the APIs, get your credentials. And the only thing here, like to point out, it's documented though, that if you are not running on Google Cloud, your server, you need to install the Google Cloud CLI on your server. And unless you are having a black credit card, I always emphasize to set up some quotas and cost limits, just to be on the safe side. Now, after we'd have our provider configured, the next step would be to set up semantic search on Liferay side. You can access the configuration in the system settings search or instance level instance settings search. The first half of the configuration screen are the provider options. So what you see there depends on the provider selected. In the case of TXT AI, it's simple. You basically just have to give your endpoint address and define the embedding vector dimensions. We have there the test configuration button where you can test your connectivity. And if there are issues, you will get notified. The second half of the screen are about how we create the embeddings and of which assets. The first two settings are about the tokens, if you still remember. So text truncation strategy means that if our asset is longer than the max character count, we have to truncate it. So that says whether we take the 10,000 characters from the beginning, from the middle, or from the end of the text. Oftentimes, the beginning is a good choice to make. Then we select for which asset types we create the embedding. And if you are using translations in your web content, you can say for which languages you want to create the embedding. Here it's important to remember that if you are using multiple languages, you have to make sure your model also supports multiple languages. Even if the model was designed for a single language, it will produce embeddings for some other language, but they just don't make any sense usually. And as our calls to embedding providers are cached, there is a setting where you can tune the cache timeout. The next step is to create a search blueprint. In order to use semantic search, you have to create a blueprint. That is a requirement. In case you'd not be familiar with search blueprints, we have pretty comprehensive resources on learn.liferay.com. But in brief, for those who don't, a search blueprint is a kind of Liferay search configuration template, allowing to configure all the aspects of search query. We can then apply this template, for example, to a search page, or for example, to a headless search request. Now, how to build this template, this blueprint? There are a few approaches. Saying it here that I'm using only one in my demonstration, but demos for other approaches are on my GitHub repo. So there are three approaches: standard search plus rescore by semantic search, hybrid search, and then pure semantic search. The standard search plus rescore is the safest way to start. So it returns the same results as standard search. It only changes the order of those by rescoring them with the help of semantic search. So it doesn't really necessarily change the original result set, but only the order of those. This is something to try if the standard search already works kind of goodish in your environment. Hybrid approach requires both keyword match and semantic match. And this is a safe approach because, for example, if your model is unable to provide reliable semantic matches there is a SafeNet keyword match to fall on. This is something to try if the model doesn't perfectly, in quotation marks, perfectly fit to the data domain, or if the domain requires exact keyword matching, like scientific environments or libraries. Hybrid approach is often a good and practical approach, I'd say. Then the pure semantic search approach, this relies on semantic similarity only. And this is great if the model fits the data domain well, but if it doesn't, it can produce confusing results. And a thing to remember here is that with this approach in Liferay, you won't get search results highlights. So you have to implement on the user interface somehow, at least at the moment. This is to try if you are having a model that fits your data domain well, or the environment prioritizes searching this way. I could imagine like cooking domains would be a good fit for this kind of approach. Now I'll show how to create this blueprint. So this is for the pure semantic search approach. And you'll soon see how it performs with Google Vertex AI Provider. What I'm going to do here, I create the blueprint, add one single element there, then I disable all the system-provided clauses to make it pure semantic search. Let's take a look. This element I'm going to add is on my GitHub resources, so you have to import that. There I have to define which asset types I limit my search to. There are some other parameters you can tune. And there I go to disable all the system-provided search clauses. And finally, I can test whether it works. It looks fine. So now we have our search blueprint to semantic search. And the final step is just to apply that to the search. So there are different scenarios where you could use this blueprint. Obviously, the first one is search page, but you can also apply the search bar suggestions, use that in the search REST API, which makes it also available for RAG chatbots. I think discussed yesterday in another presentation. And I show here how to do this on the search page. So what you need here, you need to add the blueprint options widget to your search page, select the blueprint you want to use, and that's it. Let's have a look. And there I will pick my favorite blueprint of today. Save, and now the search page is blueprint driven, but also using semantic search. Would you like to use this blueprint in a headless REST API? You just have to define the blueprint external reference code in the request. So finally, showtime. The test I was doing here, I was using local Liferay Learn site with around 2,000 articles. And I'm using the pure semantic search approach, the very same blueprint we just created. It would have been fun to show more comparisons, but within the time limits, I thought this would be an illustrative demonstration of the power. I tested only 3 search phrases. That's maybe not fair to the standard search. But as I'm on a learn site, the questions I could imagine to ask would be, how to do something. So how to create a new content page, the first challenge. How does Liferay content management work? It's a conceptual question. And how to deploy a plugin, fairly simple question. It's obvious that the 2 first ones will be challenging for keyword matching-based search because word content is everywhere on the Liferay Learn site. So, the match I hope you can see in the back row, but so our defender of the crown standard search and the search phrase, how to create a new content page. So the first hit, content page editor UI reference, off. Creating web content templates, off. Defining content relationships, off, and so on. It's not really getting what I'm asking. And the contender here, semantic search, gives me adding a page to a site, adding page, creating pages, and so on. They are maybe not perfect, but like 2 first hits are on spot. Great performance. The second challenge, how does Liferay content management work? So I want to understand how that works. Standard search gives me creating and managing experiences, managing content in content pages, filtering and sorting web content articles. None of these makes really sense to my question, what I'm actually asking. Now the contender, semantic search, how does Liferay content management work, gives me content management system, content authoring and management, content management and analytics, like exactly what I was looking for. Another point for semantic search. And the last challenge, how to deploy a plugin. Standard search seems to be feeling defeated already. The first hit, troubleshooting templates with GlowRoot free marker plugin. The second one, learning to rank, doesn't really hit my question, and so on. So completely off. And semantic search, deploying and promoting to production, deploying a custom application, installing apps, setting up automatic deployment. They are pretty perfect. And even though not every single of them would be the perfect match, the first ones definitely are. So it's a clear win to semantic search, in my opinion. Wrapping up. So the biggest question now is probably, how do I choose this model? I think 4 questions are more important than others. So how much does it know about my data domain? What data has it been trained with? Is it a good fit? This is really a crucial thing. With modern large language models, it's becoming less a problem, of course. But in specific domains, a process called fine-tuning might be needed. That means training the model further with your own data and get the model to know about your data. Second thing is, does it support my language? I already covered that. So if you want to create embeddings for English language, you have to make sure your model was trained with English data. They are multilingual models, of course, but if you don't use multiple languages, I would encourage to use these single language models. They are more effective. And how many tokens can it take? The third question. So often a couple thousand of characters is sufficient, at least it looks like that in many cases. But if you are having long assets, like this huge PDF, this might become an issue for the quality. So you might go to a model which takes more tokens. And the fourth question is, can my search engine handle all these dimensions? There are big differences how many dimensions our search engines can handle. Elasticsearch 7, for example, it can handle 2048 dimensions, while OpenSearch can handle 16,000 dimensions. So you have to choose your search engine probably accordingly. It's also very important to see that bigger isn't always better in models. For example, moving from 1.5 billion to 7 billion parameter model might not really make results noticeably better, but only costs higher. So that's something to test before making that move. And it's the same with dimensions. More dimensions doesn't necessarily mean better quality, but only performance overhead and more costs. Vertex AI is really a good example. It produces only 768 dimensions currently, but the quality is just gold. I tried, for example, with another LLM with 4,096 dimensions. It was a highly ranked model, but it was not even close to the quality of Vertex AI. And always test and evaluate properly. Eyes are sometimes good enough, and oftentimes they are really, but there are sophisticated evaluation tools also, like this Arise Phoenix, if I do remember correctly, so where you can really scientifically measure these things. How about the offerings then? If you are to go with OpenAI or Google Vertex AI, it's really simple. OpenAI gives us 3 models, while Vertex AI 6 models. But if you are going with open source, Hugging Face has over 10,000 models. So that might become more a challenge. But regardless, I encourage you to take a look at these embedding model leaderboards at Hugging Face site. That gives a good idea which direction you might want to go. So how much does it cost? As you can see here, it's really affordable. OpenAI takes only 2 cents for 1 million tokens, meaning like 4 million characters. So how much did the demo cost? How much did it cost to create embeddings for the learn.liferay.com site? It was 2,031 articles, about 8 million characters, and the cost was 20 cents. I didn't bring the company to bankruptcy with this. Future, there are certainly things to improve. These are just baby steps, I think. We don't support any REST endpoints, so of course it would be good to define your local endpoints just like that, but we don't provide that right now. We don't yet support like objects or web content structures. Something to improve, and there are other things like it would be nice to be able to do some customization to input processing. But yeah, we are on our way. Now, that concludes my presentation, and I hope I was able to show you some cool things. I wish happy exploring with semantic search. Thank you.